Hello, pre-calculus student. In this video, we're going to talk about arc length and sector in chapter 5.1. When we introduce radian as a angle measure, it opens up a lot of opportunity to use a formula that can help us to find arc length of a circle and also a sector area like partial area of a circle, like part of partial an area, not a full circle's area. So the formula that we use is S, the arc length is R theta, and which is this formula is very easily defined because we say S is the arc length, theta in radian is defined as S over R. That means how many radius this arc length is. So if you multiply both sides by R, you would get S equal to R theta, where R theta has to be in rad. I think this is to be theta. Theta is in radian. R is the radius of a circle. Yeah, I think theta is in radian. So if you know your angles in radian, you can find the arc length by multiplying that radian angle with the radius, and that is how long it is. The area of the sector is similar, so you can look at the formula that we do. Is supposed to be a pi r square of how many angle you have out of 2 pi. It's like a proportion, right? And if you simplify it, it will be 1/2 theta r square. Again, theta needs to be in radian. Okay, so let's do two applications. Suppose I have a circle of radius 10 units. What is the arc length with an angle that has a angle of pi over 6? So we would say S, find arc length means find S, is r theta, and my theta is already in radian, so I would just 10 pi over 6 exactly is so 5 pi over 3 units. Right, so that's the exact value. Find the arc length of a circle of radius 18. So I draw a circle, radius is 18, and we want to have a arc length of 210 degree. So 15 degree, right? So we want to know this as equal to r theta, but it is in radian, but my 215 is not in radian. So theta should equal to 215 times what? Remember, pi over 180 first, convert it into radian. So that would equal to, we just do 215 pi over 180, right? And so S would be R, which is 18 times 215 pi over 180. Oh, the 180 and with this cancel, so it's 215 pi over 10. Divided by 5 will be 43 pi over 2 and inches. Okay, so for exact value. So example 8, we have a area that is sustained by 30 degrees. So degree we don't want if we want to find sector area, because the area is 1/2 theta r square, where theta is in radian. So you have to change your angle to radian first, which is 30 times pi over 180 is pi over 6. We know 30 degrees pi over 6 degree. Okay, this would be degree. So now I can use it in this formula, 1/2 pi over 6. R is 20 square. So it will be 400 pi over 12, because I multiply across 20 squared is 400, and pi multiply across 2 times 6 is 12. So simplify, divide by 4, 100 pi over 3 feet. Okay, for exact value. B, in the central pivot irrigation, a large irrigation pipe rotates around the center point with a radius of 400 meter. So we're looking at this is 400 meter and radius, and what median measure should it be set to cover 400,000 square meter per day? So 400,000. So 400,000 is equal to 1/2 theta r square, 400 square. So to solve it, we times 2 divided by 4,000, right? 400,000 times 2 divided by 400 times 400. So put in the calculator as theta. So the radian measure should be 2 times 2 times 400, no, 400,000, 1, 2. Okay, 400,000, and then divided by the parenthesis of 400 square, 5. Okay, so the radian, 5 radian. So it's almost a whole circle, right? So they would cover that much area. Also when we have theta being radian, we also can talk about angular speed and linear speeds. Okay, so what is linear speed? Linear speed is the speed along a straight path, s over t. So s is, well, when I say straight path, that means just like this, right? So it's along a circle. This is s, how much it cover over time. So we call it a linear speed. Angular speed is about much rotation over time. And so it would be theta is usually in radian, and so the unit is the unit is radian per second, radian per whatever. Now, if I substitute s is equal to r theta p here, so I will see that the velocity, the angular speed is actually r omega. So to find omega, which is how much things change, we have it divided by t. And to find linear speed, we can just do r omega. This is not w, it's omega. Okay, which is actually s over t. So you can do s over t, you can also do r omega. It's faster. And in this case, this has to be in radian. Okay, it's all in radian. Omega is in radian over time. So let's see. V is the unit is feet per second or mile per hour. Angular speed omega is radian per second, radian per minute, or revolution per minute, RPM. Theta is in radian or revolution, where one revolution is 2 pi. So revolution just mean how many complete 2 pi per minute. Okay, so this is more common in real life, because when you say radian, no one will know what you're talking about. So let's do these 3 examples to look at how we use this. So these are used. These are the basic things that you should know to go into physics, because physics also cover rotational motion. Record player is rotating at a rate of 42 RPM. Wow. So 42 RPM means there's 42 revolution in a minute. What is the angular speed in radian per minute? So I know 1 revolution is 2 pi. So 42 revolution is 42 times 2 pi. So it's 84 pi radian per minute. So this is omega, the real omega. RPM is still a omega, but in layman's term. 10. An old vinyl 12-inch diameter record diameter. Okay, so R is 6 inches. Remember, it's playing on a turntable, rotating at a rate of 45 RPM. So 45 RPM. We have to change it into 45 times 2 pi radian per minute, right? But this is a minute. I want radian per second. That would be 45 times 2 pi times, this is it per minute. So I want to do divided by 1 over 1 minute. And I want to do per second, so that my second is in the denominator. So yeah, so this would cancel the minute and would have the second over. So that would equal to 90 pi over 60 radian per second. That is 3 pi over 2 radian per second. Okay, change units. Find the linear speed in inches per second. So I want linear speed, how fast is it moving at the edge? V equal to R omega, and we have omega equal to 3 pi over 2. What is the radius? The radius is 6. 6 times omega, 6 times omega, which is what we have, 3 pi over 2, 6. 3 pi over 2, that would be inches per second. So 9 pi inches per second. So at the edge of the record, things are moving at 9 pi inches per second. Example 11 is about bike. Bike is the movement of bike is, it move forward, but you can see things are moving, the angles are turning, right? So the angle turns for the bike to move. So that the 20 inches diameter means R equal to 10. So always use R. Running at 12 miles per hour, find the angular speed in radian per minute. So angular speed is, we know V is equal to R omega. This is the angular speed. So that means omega is V over R. Okay. V is 12 miles per hour, but it is in miles and this is in inches. So we have to do 12 times 12 mile times 1 miles is how many inches? 1 miles would be 5280 feet, and then 12 inches. So this is that many inches. So this is V. Okay, I'm going to erase this. And I am going to, times, so this is V, this is still V, but changing the unit to inch. I know the radius is, okay, times 1 over divided by R. R is 10 inches, right? So this would give me radian per minute. Mile per hour. Oh, this is still hour, so this is per hour. So I have to change hour also, right? Mile per, oh, I didn't write hour. Now I have to write hour. I have to write, just cancel the hour into minute. So I would say 1 hour is 60 minutes, right? So this hour and this hour would cancel, and our 60 minute will show up. So all in all, this would be written, you can calculate as 12 times 5280 times 12 over 10 times 60. And all in all, you would have the mile cancel, and it will be inches. Inches and inches cancel because it's the radius is radian per minute. So it's a lot of change of unit. 125280. 12 times 5280 divided by, oh, I have to open. What was it? 10 and 60. 10 times 60. 105.6 radian per minute. So what is RPM then? 105.6 times divided by 2 pi, because one revolution is 2 pi, would be RPM. And 105.6, I have this divided by 2, open 2 times pi here, like this. 99.3 RPM. So the row in 1 minute it's turned 99 times. Okay, it will be running at 12 miles per hour. So basically what you do is you say omega is V over R. Use this is a V, right? 12 mile per hour is V, but it's just not, this is V. It's just not in a good unit because you have mile, you have hour, our radius is inches, and we want minutes. So first of all, you change them, you change the mile into inches, right? So 1 mile is 5280 feet times 12 inches. And then you change your R. 1 hour is 60 minutes. And then have it divided by R. R is 10 inches. 10 inches, and that would be it. And to find RPM, you divide by 2 pi. So the last question, a 24 inches diameter R is equal to 12, right? We don't never use diameter, so change it right away. Rotating at 30 RPM, what is the angular speed? We know this already. 30 times 2 pi is radian per minute. What would that be? Is 60 pi radian per minute. Oh, but I want to change into mile per hour, so V is equal to R omega. So this is omega already. My R is 12 inch. So I have to change this into miles. So 1 miles, I want to change this into 1 miles is 5280 times 12 inches, right? So now the inch and inch cancel, and then I want hours. So so this is R, right? Omega is omega is 60 pi radian per minute. And I don't want minutes, so I would say 60 minutes an hour. So this out minutes and minutes cancel. I have hour. I have miles per hour. So basically that's what you do. 12 times 60 pi. 60 pi times 60 over the bottom is 5280 times 12. So that would be the linear speed. 12. I have to, yeah, well, okay, multiply is fine. 60 pi times 60. 60 times pi times 60 again, divided by this unit of parenthesis. 5280 times 12. 5280 times 12. 2.14. Oh, 2.14. This is really slow. Mile per hour. Well, you can see that if it's doing 30 RPM, it's turning very slow. This is 99 RPM is doing 12 miles. So that's how you do it. Unfortunately, for angular velocity, if you start with RPM, you always have minute. But then when you talk about linear speed, they always do miles per hour. So you have this conversion problem. Okay. So, but you use the unit vector conversion, which I will talk about in class. Okay, so this is the last videos for chapter 5.1 about using radian measure to calculate angular speed, linear speed, as well as arc length and sector area.